asking to construct interval, but we have P1 minus P2. So this is population proportion. We have two populations. That's why this is P1, P2, meaning that we should have two sample sizes and two x's. So each one of these x are number of individuals from sample. So first step, having this kind of questions, you have to find alpha again, since we're trying to find interval. Here we have 90%. So alpha is 1 minus 90% is 10%. Again, alpha divided by 2. That is 5%. Now, since we have P, we have to find Z. So that is Z, 5%. Here again, we have to subtract from 1. We have area, we have to find Z, but this is again inverse. That is inverse, but because of having Z, it's norm. 1 minus, this number is 0.95. 0, 1. I'm going to write everything for this number 1 to 3 decimal places. So that is our Z. After this, because of having 2 n and 2 x, you know that we have to find p hat. Uh, 1 and 2. So this is x1 divided by n1. And this is x2 divided by n2. I'm rounding these to 3 decimal places. Now we have to find lower bound, upper bound. So that is, make sure to find the difference between these two first. So p hat 1 minus p hat 2. Then add, subtract, margin of error. If you want, you can find E first and then add, subtract. So over E is Z times square root of P hat Q hat divided by N. Same thing here. So subtracting these two numbers first. And now this part is E. So this one is E. P hat 1 is 0.116. Q hat is 1 minus P hat, so this is 0.884 divided by sample size is 251. P hat 2 is 0.11 and Q hat is 0.89. You don't need to add a 0 at the end, but since I have all these numbers in 3 decimal places, I'm just writing it so you can see that we did 3 decimal places. So same thing here, I'm just rewriting it. Now here on this part we have two sample sizes with the same numbers, 10, 10. Here in this case we have to find degree of freedom, so we have to use the smaller sample size. It doesn't matter which one because we have same numbers. So degree of freedom is 10 minus 1. And that is 9. So this one alternative is given, mu1 is not equal to mu2, and alpha is given as 0.10. We should test. So for part A, step 1, null alternative. Alternative is given, mu1 is not equal to mu2, so here we have 210. And null is mu1 equal to mu2. Step 2, alpha is given, it's 0.10. Step 3, test statistic, we have to find t. So that is equal to x bar 1 minus x bar 2 divided by square root of standard deviation 1 squared divided by sample size plus our second standard deviation squared divided by sample size. So this one is x bar 1, this is x bar 2, standard deviation 1, standard deviation 2, and here is n1, n2. So using these numbers here on this part, x bar 1 is 17.4 minus 19.1. Standard deviation 1 is 3.9. And 110. Standard deviation 2, that is 4. Divided by sample size. Here on this part, I'm going to round. For example, to 4 decimal place, it's negative 0.9623. When you're trying to enter these numbers into calculator, first you have to find a difference between these two numbers in numerator. But if you're trying to enter all of these together, it's better to use parentheses in numerator denominator. So use parentheses to make sure the answer is correct. So this is our answer for this part. Here in this case, it's asking to test, so that means we have to find p-value. So for online assignments, when it's asking you to test, finding p-value, and when it's asking to run your p-value, you better to not run t. So when it's asking to run p, that means you shouldn't run until the end. So here in this case, it doesn't matter, that's why I run it. So for online assignment, do not run until the end. Now finding p-value. Here on this part we have two tails, so we have to find either left or right tail, and then multiply by 2. So p-value equal to 2 times this function TCDF. I'm working on left tail, so it's negative infinite over t and degree of freedom. Instead of negative infinite, you can enter a negative 9,999. Should be very large or very small number. So in this case, we have a very small number. So using TI-8384, finding TCDF, and then multiply by 2, running to 4 decimal places, the answer is 0.3610. Now that we have our p-value, we can compare that with alpha and see if we have to reject or not. So if p-value was less than alpha, we have to reject. Alpha is 0.10. So this is not less than, that means do not reject. So do not reject null. So now conclusion, this one was not word problem, but we had our alternative given. So I'm going to write, there is not sufficient evidence to conclude that mu1 is not equal to mu2. So here in step 5 we have do not reject. That's why here in step 6 I had there is not sufficient. If in step 5 we had reject, here in step 6 we should have there is sufficient. But here in this case we have there is not. So this one was part A. Now part B, construct 90% confidence interval about mu1 minus mu2. First we have to find alpha. So 1 minus 90%, this is 10%. Then divide by 2. So it's 5%. Then we have to find t. So we have 5% and degree of freedom is 9. So we should use inverse t. It's 1 minus 5%, it's 0.95, comma degree of freedom. I'm going to run this one to, same as what I did in part A, to 4 decimal places. It's 1.8331. Next step, find margin of error E. That is t times square root of s1 squared divided by n1 plus s2 squared divided by n2. So we run the t, and that was 1.8331 multiplied by our standard deviation for the first group was 3.9 squared divided by sample size plus for second group was 4 squared divided by sample size. When you're trying to enter these into a calculator, it's better to use parentheses here. Again, I'm going to run to 4 decimal place, and that is 3.2384. And finally find lower bound, upper bound. So first subtract these two. So x bar 1 minus x bar 2 minus e for lower bound and plus e for upper bound. So here we have 17.4 minus 19.1 minus e and here plus e. So the answer for lower bound is negative 4.9384, and for upper bound we have 1.5384. So this is our interval lower bound, upper bound.